This video will focus on 10.5. We're going to start by looking at just evaluating the expressions. So if I look here, I had 10 times 10 times 10, which is 1,000. 10 to the negative fourth would be 1 over 10,000. We have 10 to the fifth, which would be 100,000. 10 to the negative 2 would be 1 over 100. 10 to the 10th is a large number. And then 10 to the negative fifth would be 1 over 100,000. And what we want to really focus on today is we want to be able to read numbers that are written in scientific notation. Now, if I look at this here, I have basically a world view. So imagine going from outer space to a forest, getting closer to the forest, looking at the frog, looking at the inside of the frog's eye, and see this little thing up here? That's what this is right here. So it's getting smaller and smaller. So I have to look for the largest number here. So 10 to the fifth would be this right here. I'm just going to cross this off as I go. So 10 to the fifth is going to be, I'll just put down C. 10 to the fourth, or the 10 to the second would be the next largest thing, which would be letter B. 10 to the 0 would be this right here, which would be the forest floor, so F. 10 to the negative 1, which is like 1 over 10, would be the frog, so that'd be D. 10 to the negative second, I'm getting more magnified, right? It's getting smaller, so I'll say A. And then finally, 10 to the negative fifth would be the inside of the eye. So it's very small. And I'll just put down E. Now if I look at these here, and I'm going to match this up with the various things, if I have 10 to the times 10 to the 0, or 2 times 10 to the 0, that's really 2 times 1, right? So that would be meters. So I'll say A here. The height of the volcano, if I change this, I'm going to have 1600, 0, right? Have to go over 4 places. So 16,000 what? And we'll say feet. So this is B. For this one here, I have a length of a pen, which is 140, because I have to move this over 2 spots, so it'll be 140. Probably millimeters, so C. For the ball bearing, I will say centimeters, so that will be D. And then finally, this will be the beach ball, which is the circumference, the distance around. This right here, we talked about this in class, but on calculators, sometimes it's written like this. So 4.3 and then E10 could be the same thing as 4.3 times 10 to the 10th power. So whenever you see the E, it just means like the base 10. So the next one would be 1.2 times 10, but now to the negative 3. This would be 7.33 times 10 to the 18th power. And then finally this one here would be 9.365 times 10 to the negative 14th power. So just so I know what this means. Our key idea here is just basically how to write scientific notation. And really, it's got to be between, the decimals got to be between the first 2 whole numbers. So between 1 and less than 10. The power of 10 has to be an integer exponent, is what I have to do here. So here's an example. If I look here, it says which one is written in scientific notation. Well, A is, because it's between 1 and 10, right? It's 5 point something. This here is not between 1. It's a 0 here, right? So this is not in scientific notation. If I want to fix this, it would be 9 times 10, and then I have to move it, since I'm moving this over 1 place here, to get closer, it would be 10 to the 7th is how you'd fix it. But it's not written in scientific notation yet. Another key idea is just if you go with the decimal points, if you're going to the left, it becomes negative, and positive is to the right. So if I look at this here, in standard form, this would be going to the left. So I have to go over. So I'm going to have 3 zeros and then a 3, 2, 2. It'll look like this here. So 1, 2, 3 zeros, 3, 2, 2. So that's how you write it. This one here, it would be 4 zeros to the right. So it'd be 7, 9, and then 4 zeros. So I want you to try doing a couple yourself. So pause the video and try to solve these. And here we go. For this here, this is a really interesting experiment. So this is basically water, and it says that if something is heavier than the density of water, it will sink, and if it's lighter than the density of water, it will float. So looking at this number here, I have 1.0 times 10 to the third. This is 1.84 times 10 to the third. This number is going to be larger than this, therefore the brick will sink. The apple is 6.41, so it appears bigger, but it's only 10 to the second. So this one's actually going to be less dense, which is why apples float in water. If I want to figure this out, a dog has 100 female fleas. How much blood does it consume per day? And this is, it consumes 1.4 times 10 to the negative fifth per day. So if I would multiply this out and multiply these numbers, I get this, which will be about 1.4 milliliters of blood per day. Eesh, gross. Couple extra things I want to try. Just because we're going to be focusing on this in future lessons. If I look at this, this is 4.5. Let me just write this down. So 4.5 times 10 to the sixth. Let me try this again. 4.5 times 10 to the sixth power. And I'm going to add 3.2 times 10 to the fourth. Now the first thing, if you're adding or subtracting numbers, you have to make sure their base is the same. So if I want to change this into base 4, I have to move this over. Since this is a 6 and this is a 4, I need to get it over 2 spots, right? So I'm going to move this over 1 and 2, which means that I have 450. So I'll rewrite this as 450 times 10 to the fourth. Now this is not in scientific notation, but it's in the same notation here that I can at least add or subtract. And I'll have 3.2 times 10 to the fourth. And now I just go through here and I have 453.2 times 10 to the fourth. Now the only problem is this is not in scientific notation yet. I got to put it between the 1 and the 10 here. So it's got to go back 2 spots, right? So I'll have 4.532 times 10. And to get it back in the right location, I have to go back 2 spots, of course. So now instead of being 10 to the fourth, it'll be 10 to the sixth. And that is my answer here if I look at it. And that's really the lesson.